Hello, everyone. Welcome to our Reality Capture Education series. In today's session, we will be exploring how to master point cloud registration accuracy. I'm Christine Grail with Leica Geosystems, part of Hexagon, and I'll be your moderator for today's session. Our presenter today is Adam Westfall. Adam has more than 22 years of experience in surveying roles ranging from party chief and CAD technician to project manager, surveying director, reality capture field engineer, and business owner. As reality capture consultant for Leica Geosystems, Adam focuses on helping surveying and engineering firms achieve transformational innovation with laser scanning technology. Today's session is live and interactive, so please do ask questions and make comments as we go through the material. Adam has a lot to cover today, so we might run a few minutes over on time. If you need to drop off, we completely understand, but we hope that you will find this a very engaging session. If you do have questions, please enter those at any time during the questions box, which you should see on your screen, and we will address those with Adam as time permits. Also on the line with us today is Leica reality capture consultant Eric Cowan, who will be responding to your comments and questions behind the scenes. Before we get started today, we do have a couple of quick polls we'd like to share just to get a better idea of who is in the audience today. The first poll that we have, which you should see up on your screen right now, is how would you describe your experience with laser scanning? Go ahead and take a moment to answer that poll for us. It looks like we've got a number of people in the audience who have experience, but they're still learning. And I think that probably describes even the pros who are in the audience with us today, because there's always something to learn, right? So I'm going to go ahead and close this out and share the results so that everyone can get an understanding of kind of where you fit in. And then we have just one more quick poll here that I'd like to share, and that is, are you already using Leica laser scanning technology? Kind of a quick yes or no. And of course, if that answer is no, we hope that it's no, you're not using Leica yet. And I think some of the things that you'll see and hear from Adam today will help you understand that strength that the Leica technology brings to your operations in terms of quality and speed and other things. So, all right, it looks like we do have a lot of people on the line who do use Leica. That's fantastic. So I'm going to go ahead and close this out and share the results. And with that, I am going to go ahead and turn it over to Adam. Give me just a second here. All right, Adam, whenever you're ready, you can go ahead and take it away.
Sure, thanks, Christine. It's my screen getting shared so far?
Yes, I do see that.
Okay. So thanks everyone for joining me this afternoon. Laser scanning accuracy, precision is kind of at the heart of everything we do, whether it's laser scanning, surveying, even if you only want, 5-foot GIS accurate locations, there's still certain practices and equipment you have to use to achieve that. And to be honest, a lot of us get into laser scanning because of some of the promises that it offers for high accuracy, high precision. And so first of all, we're going to start kind of at the fundamentals, and we're going to go through a little bit of the theoretical and into the practical at the end. And today I'm going to, like Christine said, I'm going to be covering quite a bit. It's not intended completely to be training, mostly informational, point you in the right direction. And to that end, I mean, I hope you learn quite a bit, but to that end, I'm going to be moving pretty quickly. And if you have specific pointing questions that we need to dive deep on, feel free to send your contact information into that question chat window, and we'll reach back out later with in-depth if you want to cover something. And there's also canned training materials that we have available. Christine will point you to those later. But first of all, talking about registration
Adam, I don't
accuracy.
think we're seeing the presentation. If you have a slide.
I haven't drug it over to my screen yet.
Thank you.
So first of all, can you see this graphic?
Yes, but you might want to expand it.
Yeah, so I believe surveyors get in trouble if we don't show this graphic when we talk about precision and accuracy. So the top left, that's a representation of low accuracy, low precision. You're not really hitting the mark you want to hit, and you're not able to repeat your effort. The top right, that's a representation of low accuracy, high precision. That's something like you have your random errors are pretty well controlled, but your total station might have a collimation issue. That would be a systematic error, or you have a bad prism constant or a bad target height. You're hitting the same thing over and over and over, but you're not correct. And in the bottom left, you have high accuracy, low precision. So you average to the right value, but you got quite a bit of random error probably. And the bottom right's one we want to see, high accuracy, high precision, where you're getting close to the correct value and you're able to repeat that. And the way I always like to look at this is, if I'm going out trying to put food on the table, shoot at say a deer or something, I like the bottom right because that gets me fed more often. And everybody's heard the joke where the 3 statisticians went duck hunting, and the bottom one, the first one shot low, and the second one shot high, and the third one said, "We got him." But that doesn't exactly apply in survey. You got to hit the right value. And to deep dive and to do kind of an extrapolation on that theory or that concept is, let's take a look at the actual data sheet. We're going to focus today on talking about the RTC 360. And this is the data sheet. It's available for download over in the the webinar manual. And this data sheet has all the things like the weight, the batteries, some electronics information, environmental operating temperatures, but really what we want to take a look at here is this accuracy and range noise panel. So if you have a certain accuracy that you're trying to achieve for your project, if you want to do a monitoring project or high accuracy as-built analysis or something like a bolt pattern, then this is really where you need to start. You need to understand the performance of the sensor that you are using. And one key takeaway with a laser scanning data sheet is this is a single point measurement statistic. So if we look in this accuracy pane, we have angular accuracy 18 seconds, range accuracy 1 millimeter plus 10 parts per million, and then it breaks down below that. 3D point accuracy is 1.9, basically 2 millimeters at 10 meters, 3 millimeters at 20 meters, 5.3 millimeters at 40 meters. And then another really important characteristic is this range noise. The RTC is a nice low noise machine. You've got basically 0.5 millimeter at 10 meters and 20 meters, 0.1 millimeter difference. But to relate this back to that graphic we talked about with the accuracy and precision, so this would be your accuracy. This gray, which we call it accuracy. Range noise, another way to say that is precision. So if you have a plane 20 meters away and you're measuring a point on that plane, your expected performance is about 3 millimeters, and it's going to waver back and forth about 0.5 millimeter either way. And so you've got the accuracy of the distance and angular measurement, and you've got the precision of the repeatability of that measurement. And again, what we were saying earlier is this is the characteristics of the RTC 360 when it measures a single point. And in practice, unless you're looking at a fine edge or you need to do something like really what this single point accuracy matters the most is if you're trying to do something like size a conduit or size the webbing on steel. A lot of those, like the end user wants to know that size to 1/16 of a millimeter, and unless you're really, really close to that steel, you're going to have to use calipers and make a note. And you can model the spacing, the spatial representation of where that steel is accurately, but some of these things you need to go a higher order of measurement like calipers so that you know the actual webbing thickness. So and I only bring that out because just because you can pull a catalog measurement out of the catalog in whatever steel fitting software you're using, that doesn't mean that the noise and the range accuracy allows you to accurately determine that measurement. And to develop this concept a little bit farther, this is RTC 360 data. The same wall. Now it's not a perfect wall. It's got some bowing and flexing. It's not perfectly plumb. This is a hand laid brick wall. I believe it was 6-inch brick. And this is a slice of that wall taken 50 feet away. It's got a certain characteristic of noise. And this is the same slice taken 150 feet away. And I believe I got the slice a little higher because there's a vent pocket in the top of the brick. But really what I wanted you to see here is this, the spread of the points. the points 150 feet away have that noise, that range noise characteristic that is set forth on the data sheet. The 50 feet, you got a tighter, more average data set. But the beauty of these two is either of these walls, if you mesh and you use the proper meshing technique, you get the same average location for where this wall would mesh to on either of these data sets. Now, one won't be as high resolution like the 150 feet away. I've personally meshed this wall. You can, if you want to crank like in 3DR, if you take your sampling down to 2000ths, you can get the individual mortar joints in the mesh. Now, the 150 feet away, you're going to get an accurate representation where the plane of the wall is, but you're not going to see things like mortar joints. So now let's move on. And today, the point whenever I do a webinar, I like to focus on what I would consider the key takeaways. And key takeaway number one is the scan spacing and overlap is a critical element to when you're doing cloud-to-cloud registrations. And the to show some graphics that represent that, I have a YouTube video that I've published where whenever I price out a project back when I was in the private side, when I was doing scanning for hire or scanning for a project internally, I would draw these 12.5 meter radius circles and I would place them where I would think I would need the scans on the site and count them up. And that's how I priced the scanning project. And the scan spacing at low resolution, you tend to get, and I have another YouTube video about resolution that I suggest you watch to understand why I usually recommend low resolution. If you space your scans every 25 feet, so 12.5 radius is 25 feet across from scan to scan, then you're able to completely cover this entire site. And that 25-foot spacing usually gives, and that's kind of a maximum spacing, but it gives you a really nice overlap and leans really heavily into the automated side of things when you bring your raw data into Register 360 Plus for its ability to quickly generate the correct links and the correct registrations. And here's that same 25-foot spacing if you distance filter it down to 75 feet. So you see you get a ridiculous amount of redundant data. And if you remember, I didn't actually put circles here in the center of this, or there's an open gap here. And that's because you don't have to put scans to get exhaustive scan data on every single part of your site. Now, another concept of the automation that you get when you bring things into Register 360 Plus is how you actually generate the scan data in Field 360. And Field 360 is the companion app that runs on the Android tablet or the iPad. And there's a handful of options you have when you create the links. And I recommend, unless you're doing a big, boring topo where you're going to push it up to medium and go every 40 to 50 feet between your scans just because there's not a lot of features and you can lean heavily on the GNSS and the RTC 360. If you're not, usually we laser scan because there's a lot of features, a lot of detail. So I crank it down to low res, get more scans because it's less data. A low res scan without photos is only 40 megabytes. And with adaptive image resolution turned on, it's only an additional 40 megabytes. So it's only 80 megabytes per scan. And this first option, this quick link, after you generate 2 scans, quick link is available for scanners that have Viz. And Viz, you see the scans are pretty much already placed where they go. But in the past, I've seen quick link, it can manifest some issues because it basically, the Viz is really accurate, but the quick link option is not much better than Viz. It connects and it does a very lightweight calculation based on nearest point neighbor. And you can tell it's not doing a very robust calculation because it generates that link almost instantaneously when you hit quick link. And then the second option you have in Field 360 is pre-align. That's a little checkbox. Pre-align is for a situation like this where you don't have Viz. Setup 1 and setup 2 are not in the correct place. It's something like using a VLK 360 G1 or a P-series scanner that I love using the P-series scan with Field 360. And if you check pre-align, it'll do a quick calculation and try to figure out the translation rotation between those scans, how they go together. And this one you can tell scan 1 was taken probably at the top of a spiral staircase and scan 2 had gone down a little ways. And it's really good for that. But if you have Viz, you're kind of undoing some of the technology if you check pre-align, because it's ignoring the fact that there was already a viz solution. So what I prefer to do is just the create link, you select one, select two, and then you jump into optimize. And this is something I wanted to show these slides honestly for this key takeaway. This level of detail was not was not an option until Field 360 4.0 came out. And I don't know if anybody watched LinkedIn or the different distribution channels, but Field 360 5.0 went live yesterday, which allows for use of the BLK2GO and the new BLK2GO Pulse. But this level of detail actually drives the calculation, the how many points are used to do this link creation calculation. And I believe if you dive into the documentation, you probably don't want to use high unless you're using something like a high-end tablet like an iPad Pro. You're probably going to want to do low or medium. That way you don't flood the cache of the tablet that you're using. But so I'll pause at this point, and Eric or Christine, just let me know if you've seen any kind of common thread to the questions, if anybody has any questions at this point.
No, I think you're good
No
right now, Adam.
questions,
Why don't you go ahead and keep going?
Okay. So let's jump back into those key takeaways. Didn't mean to give it away, but that's the second one. I like to always make sure that I'm using the optimized routine when I'm creating links. And the others are handy, like if you're doing a big area that has unique geometry and you know that the registration is going to be like outside, quick link might be a little more user friendly than optimized just because it's fast. And like I said, if it's not something that has a lot of, like if you're doing cubicles, you don't want to use quick link because you want to make sure you've got the right spacing. If you've got similar geometries, you want to do a little bit of QA/QC. So another tip trick that I like to tell the crews when they're using Field 360 is, and I've had one customer in particular that they were doing a lot of distribution lines, and the road that they were scanning down was just a tar and chip road, and it was vegetation on both sides, but they had a power line overhead that they were trying to scan. And when they were doing the typical 20-25 feet, sometimes they would see when they made the link, the one scan would jump and it would move quite a bit. The viz by itself has a 1 in 100 accuracy usually. So if you pick that scanner up and you move it 25 feet, it usually knows where it is within about 0.25 feet. And I've found that to be pretty reliable, pretty predictable. And when you go to create that link, if it jumps, I would hit cancel, don't create that link. And when you hit cancel, it doesn't move the scan. It puts it where Viz had it. And then I would actually back up and put a scan in between the two, make those links out of sequence, do like 2, 4, 3, and then go ahead from 3 and do 5. And that's an indicator that now the laptop, the computer, when you bring it in the office, it has more data. Just because the iPad messed up the link doesn't mean the computer, the PC will, but you don't want to make a bad link because you're taking away some of the automation and some of the speed that is in Field 360, the RTC 360. And that's another neat component of something that used to not be synonymous with surveying at all, is that speed can equal accuracy because redundancy means more data, better solution, and speed means more redundancy. So you can do more scans. Now, I've done a lot of scans in the past where the customer wanted photos, but to get a very automated registration, I did photos every other scan, and I tightened up my scan distance because I didn't need photos every 15, 20 feet. It was a very irregular indoor space with a lot of there was a lot of staged material that I was worried might not register really well. So I tightened my scan spacing up, and I had photos every 30 feet, but I had scans every 15 feet because a scan without photos is only 30 seconds. So, now I'm going to move into an Open Register 360. So this is, I went out the other day, this past Tuesday morning, and I did this scan for the purpose of showing what you can achieve when you do lean on best practices. And this, honestly, I didn't even notice till I got down here on this site. This site has a choke point right here in this corner. And so there's some things, some best practices that if you follow with the scanning, you're always going to get really accurate numbers. And like, see, these global errors are all down to 0. And the basically I imported this. It said 5 thousandths. You're really accurate, and you see this lock when it comes in. It always imports it and locks it because if it gets, and it excuse me. If it gets a solution within parameters that you have preset, it will just automatically say, yeah, you're good to go. This is finished. And you need to be careful. You still need to do some QA/QCs, and I'll show you some example of that here in a little bit. But in this case, this one was absolutely perfectly good to go. I could throw it on control right now. And for the purpose of what we're talking about today, we're not going to talk about targets at all, because I don't think I could get that topic in this. Maybe we'll follow up later with and expand on an advanced version of this topic that uses targets. But really the strength and the secret of the RTC 360 with the speed is once you learn how to do these cloud-to-cloud registrations, there's really no need to go back. They're really good as long as you tailor your approach to the environment that you're scanning in. And so first thing, Register 360 Plus, it's a guided software. You have this import, review and optimize, finalize, report. So you're always moving through this progression sequence of events. And if you click on an individual link, you can see the statistics for this link. And if you click on the bundle, you see the statistics for the bundle. And before we move on, let's do a little bit of glossary. Just kind of that we're speaking a common language for today. And this is all straight out of the help menu for our Register 360 Plus. So the global error is very similar to what you see in Register Core back in Cyclone Core. And that global error is that's that links column, the constraints column. When you get a really good solution, a lot of times those are all zeros. And it's the global error for a bundle, shows the amount of setup movement when global optimization is applied. So basically, if you have a network of scans or a loop of scans, a loop you should almost always see zero with good practice, because what it's saying is we're able to make the beginning point equal the end point and not move any scan outside of its estimated accuracy for the link. So it's saying, hey, we're not seeing any adjustment residuals at all in this loop, so it's zero. That does not mean your accuracy is zero. That means that your adjustment outside of your expected need for adjustment is zero. The bundle error is the overall error for all the links in the bundle. And this is a major difference between Register 360 Plus and Cyclone Register Core. Cyclone Register Core gave you error vector and bundle error, but it wasn't really a persistent and in your face. And it also would give you that little histogram that would show you the cloud-to-cloud fit. And it would say, this cloud-to-cloud fit within 7 millimeters, and then that window went away and you never saw it again. Register 360 Plus, that data is persistent and it's in your face. And I routinely hear, I have customers that love Register 360 Plus, but I also hear some people say you'll get Core when you pry it from my cold dead hands. And I think the reason for that is, now, we all love software that we really know how to use, but the truth is Register 360 Plus is very easy to learn and easy to use as long as you embrace the scan overlap and scan spacing concept. It's very automated. And I think the reason people think that they're not getting as good of solutions in 360 Plus as they were in Core is because, to be honest, 360 Plus is a little more honest, a little more transparent. It keeps those misalignments or the actual accuracy statistics per link and per bundle, it keeps those in your face. And strength is kind of a new thing, and it's honestly the strength indicators. A lot of the reason I wanted to have this particular topic for the webinar, it's a new potential quality indicator, and strength alone is not that important of a number. Like you saw when I clicked on the one earlier, it only said 12%, but we'll cover why that what that means. And strength is relative to the 6 degrees of freedom. So if you have, you tend to have close to 100% in the Z plane. And that's because you're never going to scan anywhere that doesn't have a floor or a floor and a ceiling or the ground. So you have a lot of data on that Z axis. And if you're scanning on a corridor that you've only got a building on one side, you're probably going to have low strength. That doesn't mean it's poor strength or an unreliable link. But it's an indicator that if you have low strength, that is an outlier from some of your other numbers, like it's down around 2%, 3%, or 5%, the others are up around 100, then maybe that's one you need to look at if you're having some issues. We'll take a dive on what that actually means a little more here in a minute. And a new checkbox that's in your settings is advanced optimization. And it sounds hard to explain, but really what it means is if, like I have a customer, I was just looking at a project with them, they did inside a warehouse has over 2,000 scans. And if you check advanced optimization, it speeds up your ability to QA QC and tweak that, because if you fix links or fix something in a small area, it doesn't try to re-optimize all 2,000 links. It tries to do sub 500, what it can do pretty quickly. And then when you click back on the bundle and say optimize bundle, it optimizes them all. Now, one thing to keep in mind is if you have an issue or there's something like a field technician created a link incorrectly and you're trying to figure it out, you need to hit re-optimize for the bundle to make sure to see if you fixed what you're, and you always have to look at True Slicer. That's something we're going to look at later. But the advanced optimization is helpful if you have really big projects that you're working on. So to jump back and look into the strength number a little bit more, the strength for this entire loop, and a loop classically is not really all that strong for scanning. A loop doesn't give you a ton of redundancy. You've got really one point that you're kind of closing out to, like a traverse. And while we discuss that, before we go too far off, let's look at this graphic really quickly. And this is pretty simplified, but and I've seen numbers like this manifest before in registration software, where if you have a loop, you think you're doing better than you are really, because let's say you went out and you did a 10,000 foot traverse, these legs added up to 10,000 feet, and you closed out a tenth, so it's a 1 in 100,000 closure. But it's like, say, pretend this is 0.1 and 0.2 where you closed here. Your coordinate tie where you closed out was a tenth. If you ran this through Bowditch rule or least squares on a loop is really just Bowditch rule. It kind of proportionately tweaks your angles and distances to get a perfect closure on this one coordinate, but that 1/10 doesn't go away. You've got 100,000 closure, but that 1/10 is over here. It's always opposite where you closed, because that's the farthest from your coordinate tie. So you've got a perfect air ellipse theoretically here and a tenth here. But you've got that 1 in 100,000. 30, 40 years ago, if you said 1 in 100,000, people were celebrating and hooting and hollering. Then there became some discussion when least squares kind of started to come about, things like Stardet and like a GeoOffice, where if you were to do one cross tie, you would get much tighter air ellipses. It'd be more like 300ths, because it would be your angles minus one. That one cross tie it wouldn't be half. It would be half minus another observation, because you have more redundancy. So your air ellipses are now 300ths, but your closure doesn't sound as good. You actually now have two 1 in 50,000 loops. And some of the people who didn't understand the new concepts were thinking, oh, that's only half as good. But if you were staking curb and gutter across this subdivision, if that's what this was, and everybody knows that's ever had to do it, if you staked curb and gutter here and turned in and then over here, you might have a 1/10 bust in your curb line. Whereas this one, the worst bust you're going to have is probably 3 to 400ths. And then laser scanning is more like usually a scanning network is more like this figure on the right. It's not a perfect apples to apples scenario, because these laser scanning links, even though it kind of looks like a traverse, it's not slope distance, horizontal, vertical angle, setup error. It's not the same thing as, like, those are kind of multi-component vectors from station to station, whereas laser scanning, each link, it's a mathematical understanding of translation, rotation, pitch, yaw, roll, and it's just static numbers. It says, okay, from this scan to this scan, based on how the clouds overlap, we have this delta of numbers and this stated certainty, and that certainty, that link error. So if I pick one link, this is scan 1 to 2, link error is 5,000ths. And the reason the global error is 0 is because it's saying it didn't have to displace either one of these more than about 5,000ths, or the accumulation as you come around the loop. And so this strength is saying it's only 18%. And the reason for that is I actually have a UCS that if you kick a UCS, I think it actually changes your strength reporting to be a little more aligned with your axis. So let's click this link and pause on the strength. Your x-axis is only 17%, your y is 19%, and z is 100. And that's because x, it's saying you've only got like this this scan saw down this side of the building just a little bit, and there's some glass in here that if I actually already trimmed this refracted data out. And if you're really chasing good numbers reporting, sometimes you're going to want to get rid of this refracted data for your cloud-to-cloud solution. And the reason I said that the way I did, if you're chasing really good numbers in your report, it's probably not going to change anything with the position for the scan. So this link could say 500s, but because there might be a couple trees or bushes coincidental to the scan, that doesn't mean that the link is less accurate. If you do true scan, if you open the visual alignment and you trim those bushes out, and so let's actually just play with cleaning this. And these were distance filtered down to 100 feet, but okay, cars are not really good registration object. So we've got an 81% overlap and 5 thousandths, and this is totally unnecessary. But let's trim these cars out. And this trimming in your link view does not do anything to your model space. All this will still stay in your model space. And I'm going to go ahead and trim out all this behind it because that's only orange. There's no overlap. And I'm just going to say delete inside and re-optimize. Now I'm down to 1,000th. So that sounds like it's 5 times better than it used to be. The truth is, it did not change the characteristics of this link probably at all. It just changed what it was reporting for the link. So just bear in mind that you're not, just because you can make your numbers look better, it doesn't always mean that you're actually doing or being better. Now let's look at the strength back here along this wall. You've got you've got a gabion basket wall on this side and the actual wall of the store on this side. So X 66%, Y 93, Z 100. So I think my X is actually turned. This is X, because if you look, let's open the visual alignment. So this direction, there's actually not much planar to constrain it sliding up and down this alley, but there's a lot to constrain it this way and up and down. And just because there's not a lot to constrain it, the new on this one axis going up and down, like kind of a center line of the alley, that does not mean that it's weak, because if you were in an office building where this was a perfectly flat, smooth floor, it would be something to worry about. But this concrete, asphalt, whatever this was, this undulates, so it actually has a good understanding of the positioning along this axis for these two scans too. Not to mention you've got irregularity on these walls, and I don't know what the inner workings of what we did for the cloud-to-cloud solution, but I kind of got the feeling that with the advent of Viz, where the cloud-to-cloud didn't have to figure out 20 feet, it was more like it was only working on 0.2 feet. It's almost like instead of big planes, it's really subdividing these clouds now down into really small planes to getting much more data to put into the solution for getting the individual cloud to clouds, if that makes sense. So now this loop opened this, it's pretty well good to go, as I previously said. Let me make sure I'm not skipping over anything really quickly. Okay, so the refracted data, let's look at one of those again really quick. Let's open this, let's look at the bundle view, and let's get a couple that we're in front of. So let's do these two. This link here, should have seen in these windows. And if you open visual alignment and then you can bring back the data, there's not a ton of overlap inside this refracted data. And I'm fairly certain it's not going to influence the solution, the actual position of the scan, but it will. Let's join and optimize and see what we get. So 2,000 to 86%, jump back in. The thing to remember is that the scan here had refraction, they refract different ways. So it's not a systematic, it is systematic per scan, but the systematic errors do not agree between the scans. That's a pretty important concept. So, and as I said, it's not actually going to affect the reliability or the applicability of the solution that you're getting in the link, but it will make your numbers report a little better if you get rid of this. And honestly, I'm going to go ahead and get rid of this car too. So joining. So 1,087%. So, and this isn't really, this is kind of statistical housekeeping. You're not, as I've said it several times, you're not really changing the data. You're just, if you need that registration report and you want everything to be green or green and yellow, sometimes I actually go in and I change these thresholds to where they're really low. That way I actually get some variation of color, because the RTC and Register 360 Plus are so good these days. If you don't really crank these down, everything's just going to be green. But if anybody's interested in the settings, these are the settings I usually use. And I don't really like this optimize upon link creation. If I have a scan that comes in perfect, I'll leave that on. But the truth is, sometimes if you're teasing out, if there's a potential error in a scan, I turn that off because it helps me work piecemeal and I don't feel like I'm chasing numbers that are always changing on me. And this is another really important concept. So if you're not using Viz, you're just using the GNSS, you might need to bump this out to like 6 feet, because you don't know that the scans are any better than your GNSS solution. But if I'm using Viz, I can do this down to 2/10, 1/10, and I usually just crank this all the way up, this all the way down, and because of that Viz solution, it's really not searching high and low to get the right answer. It's already, especially if you're using Field 360, it's really close to the right answer. And this view of the parking lot's a pretty good representation of how you've got multiple planes now, compared to in the past it might have said, well, this is just one plane, this is one plane. Now it's saying plane, 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 plane. So it's like having several common targets. So let's close this scan, and I'm actually going to open the exact same project. I tightened those scans up to about every 18 to 20 feet. And this is if I only did them every 40 feet. And you see it's still good. You could still use this data. It's almost a joke. It's a hundredth and a half. But if you look at your global error, it's saying down around 1,000. And I've got some of these, if you click, it's saying 200ths. But let's look at the bundle and jump into True Slicer. I'm gonna turn the scans off. And with True Slicer, this thickness, it's 2 meters. If you turn it all the way up, if you turn it, I like to run it down to about where I'm looking, about 3-4 centimeters. And if you come in and look at this corner of the building, like you see all this, the one said 200ths, there's nothing 200ths out in this. Everything is perfectly nice, smoothly coincidental. The one thing you always want to check though is don't just look at the top-down plan view. Always look at some cross sections, because the devil can be in the details of your verticality. And we're going to cover that a little bit here in another data set we're getting ready to look at. But this, and as again I said, this is kind of a joke. This bundle, your bundle error is still 100th and a half, and that's with about an average of 40-foot scan spacing. So I'm totally negligent of what I consider my own best practices. But I will say that if you space this out to 40 feet, this is 40 feet where the laptop generated the links. If you did 40 feet with the iPad generating the links, where it's only using about 2 to 5% of the data, depending on that level of detail you have turned on, you're going to have issues. It's not going to quickly automatically find the right answer at 40 feet. It's going to have, there's going to be some places where you get wrong planes get matched and so forth. But let's looking at this is a better one to look at because you've actually got some numbers here. But this bundle error, overlap, strength, cloud to cloud, all these errors are indicators of like this global error. Like I said earlier, this is like your constraints list in core. And let me pull this up. This is the same project, the better version, the every 20 feet registered in core, and it looks perfect. I still like seeing this perfect zeros column error, and so you still have your, this is kind of like your bundle. If you average these, you would get the 5,000ths that we had in the other one. And then if you look at your diagnostic, the report that you get, this is kind of where I think people get a little misled. It says 00. Core is awesome software, but I really like that Field 360 is a little more transparent in what it's telling you. So that's our third takeaway, that the biggest difference between Register 360 Plus and Core is that Plus reports bundle error in addition to global error. Core only reports global error. So basically what Core is saying is we didn't adjust anything more than we thought we would, so you're good to go. And Core is saying, 360 Plus is saying, we got a good adjustment, but there's still places where if you pick a coordinate on a feature from this scan versus this scan, you might get 6 millimeters, 8 millimeters difference. And that's really an important concept to understand, because everything we ever do has error. Nothing is ever truly perfect. The good surveyor, the good scanning technician knows how to properly allow for, plan for, and manage that error, not pretend like it doesn't exist. So moving on, let's see what I was going to do. Oh, so I've got another project here that I wanted to show you real quick.
Before you do that, Adam, could we
Yes.
pause just a minute? We did have a question about if you could show your settings for registrations. Someone only saw the link setting, but they're curious about your settings for registrations. Would that be something that you could share before you move on to the next data set?
Yeah, there's not a ton of different settings. This is what I was showing for registrations, is this the search radius and iterations. So just because you have this cranked up to 300, so in core, you could change that variance, the threshold, convergence threshold. That's a set data point in here. You can't change that. But just because you have this set to 300, that doesn't mean it doesn't find the answer after 50. So setting this up higher if needed is not something to worry about, especially if you have a small search radius. But if you have a project that's got 1,000 scans and you don't know how they go together, you might crank this up to 1,000 and crank this up to 10 feet and see if it gets what it can do automatically, just auto cloud, before you come back the next day, let it run overnight. Of course, 1,000 scans probably wouldn't even be finished with those digits. But so this is all I set my green and yellow based on what I need for the project, and it's the same with the targets. We'll talk about targets a little bit at the end, but the targets is really respective of your accuracy with your survey, and that's an entirely different discussion. But we'll talk about it here in a little bit, pretending that you get better than scanning with a total station and slightly worse than scanning with VRS or GPS. And I usually turn this off. This allows link creation across sitemaps. That's up to you if you want to, before you even import, if you want to try to say, well, this links to this. I don't personally see much benefit in that, because you get different sitemaps get different bundles when it comes in, and you can just connect those later. In this advanced optimization, we covered that. That's really only comes into play if you have more than 500 scans. So this, go ahead.
Yeah, just real quick before we move on to the next data set, and they might be the same, but we had someone who wanted to know which check boxes you had checked when you imported the data.
Oh, so okay, good question. So if you're using the RTC 360 on import, I turn basically everything off, because if you're making links with the iPad, this is already done. You don't need this. If you have spheres, like if you're in the woods and you need really high accuracy, then really you're going to have to use spheres. And one time I did a project indoors that had these sound curtains on both sides, and they would slightly move, and I was chasing well under a centimeter. The only way you could do that is we had to go get 6 spheres, and we had a second person help, and they were moving the spheres ahead every scan. But you still have to obey. It's really good. The spheres is really cool if you still obey the 25-foot scan spacing. Put 3 spheres between each scan. You need 6. That way you can leapfrog the spheres, and that way your spheres are never more from the scanner than about 12.5 feet. And back in the old days of core, you had to be really careful to either number them or make sure they weren't in somewhat similar configurations. You can put them in absolutely the same configuration between each scan and use your tablet to generate the links. And the nice thing about that is if there's spheres here and here and here, but you have the links, Register 360 Plus can auto-populate those spheres, and they don't even need to be named. It just knows there's 3 spheres here, there's 3 spheres here. That's hard to say. On, and it will automatically generate the registration link based on spheres, and you can just delete the cloud-to-cloud links later, and you have a spheres-based registration. Almost completely automatic, other than somebody had to move a bunch of spheres around. And sometimes if I think I'm going to need troubleshooting, I leave this off. That way I get my distance as far out as I can. But if I have something where the iPad looked great, it's a crew that I know they know what they're doing. They've done hundreds of scans. I usually go ahead and upon import, I'll distance filter this down to, if it's topo, 100 feet. If it's indoors, probably 75 feet. That way I just get ultra cleanliness on my data. Because if you remember that this picture that we looked at the top of the discussion, the noise level at 150 feet is considerably more than it is at 50 or 75. And that tends to not be a very linear line. Like once you get out to 100, 150, that noise kind of curves upward. It gets very noisy at about 250, 300 feet. So this data set, really what I wanted to look at is, I don't know if we've all seen this where we've got these issues with there's a bad link somewhere, and in core what I would do is I'd sort by error, fix the one with the worst error, re-register, sort again, and just keep doing that. The main difference when you seem hard to chase one of these down and register 360 plus, usually it's somebody has done something like this. See how every scan is leveled? With the RTC 360, the leveling that it does is if the scan head is within 10 degrees of level, it will apply level based on the IMU to within 17 seconds. And that's with good practices if a scan's level within 10 degrees. That's a great feature, but the thing to keep in mind is you don't want to do that every scan like it was done here, because let's say 17 seconds is a pretty wide range. It's good enough for one scan and for quite a bit of distance, but let's say it got plumb out 10 seconds, that's within 10 seconds, and scan 1 is 10 seconds, scan 2 is 10 seconds the other way, that's 20 seconds. If I remember my math correctly, 20 seconds at 100 feet is a hundredth. So that's 6 millimeters of tilt that it's constrained from adjusting that out of these scans at 100 feet. And these buildings, if you look at these, I think some of these are more than 100 feet. And so let's also look at top down. This one had a lot of issues. This is raw import. This building is ghosted. Let's kick it in the true slicer so you can really tell. So I think somebody was looking at these scans here and they got the wrong bump outs on this, because there's so you have several scans coincidental here, and then you have the same building and then different layers of incorrectness. And actually these, I've already been through this data set with the fine tooth comb. These are tilt errors, because probably usually what happens is either it wasn't within 10 degrees, so it didn't get anywhere near 17 seconds of accuracy applied on the tilt. But also, one thing to keep in mind with the tilt on the RTC 360, where it's IMU based, if it is sitting next to some source of electromagnetic interference, it can be perfectly plumb and it might pull it off of plumb. So what I tend to do is I look around, look up, look down. If I'm in a good space, I'll do a high accuracy tilt scan here, I might do one here, and I might do one here. And that way I get it. If you should average out to quite a bit better than 17 seconds across the site, because I did it 3 times, but it allows each individual scan to adjust and massage that tilt out between the network between scans. Because the first thing I can do 200, and this data set's got a lot of problems, but the first thing I did was toggle off the tilt, told it to not constrain the tilt, and I got it down the about 8 thousandths, a hundredth. And obviously I had to go through and fix all these coincidental issues. But that's another key takeaway with the tilt, is if you don't unconstrain that, the software is unable to free up that Z-axis to get a better numbers. And if it's locked, you can fix these 5-foot displacements, but you're still going to see 200ths, 500ths, and it's just going to kind of rubber band around because it's getting the best fit it can with the tilt that is in the data. So let's talk about control for a second. Now, on this site like this, if you can lock or unlock your scan to scan. Now, whether I'm using Total Station or GNSS, I always lock to begin with and then apply the control. Because if it's Total Station, I'm going to suspect that it's better than my network of scans, because if you know how it works, like this is brick buildings, it's asphalt, you're very accurate. But by the time you go from 1, 2, 3, 4, 5 links, even if it's 7 thousandths per link, they don't add up, but say they did, that's 3.5 hundredths. across this down this, and you can get much better than 3.5 if you set a total station up and shoot a prism. So the total station is going to be more precise, a little more accurate than your scan data on best practice. But if you lock this and you say you have 5 or 6 control points that you're going to constrain it to, if your delta jumps up on one, say a tenth, well, that's a pretty good indicator that there might be a prism constant. Or if it's half a foot, let's say it's probably got a measure up problem with that target. So I like to lock first to get a QA/QC against my my scan data for the total station data. And then when I apply, if I get something like 300ths, then I'm going to say, well, that's pretty much matches what I would expect to get with the accuracy I have between each link and what I'm getting out of my least squares adjustment for my survey data. So then I delete the application and control, I unlock and I apply control, and then that floats it out and locks it. And conversely, if this was VRS at Urban Canyon, you probably wouldn't even try to do GPS. But the if it was sub-centimeter, I just leave it locked and let it distribute that error out to the control points. But so that's locking before or after. It just has to do with whether you expect your control to be more or less accurate or precise than your scan data. And the big key takeaway, probably the most important thing we're going to talk about today, is WYSIWYG. What you see is what you get. So let's make a UCS real quick. And to do that, you jump into sitemap, click a station. Let's make a UCS here, and we'll try to turn it up as building face, kind of like that. Let's create it, and just, I could edit it, call it something like temporary, but it's fine. Let's leave it the way it is. And let's kick in the true slicer. I like to make the UCS, that way true slicer runs. And I always like make sure true slice is in ortho. So the everything looks beautiful. It looks nice and coincidental. There's a lot of stoops and features on this. I think that's a ramp coming up into this building. But this is really what you hang your hat on. Numbers are great, but like when I opened that raw data set of this data, I immediately saw that there were issues because there was ghosting on the building. And then like I said previously, always kick in and look at your y-axis. I usually kick the stations off when I do that. Run your station up the road. Curb line. Face a building. And I'd say if you did find an anomaly, something you wanted to address, then you pick setups and you say, well, why is it I'm seeing mismatches between scans setup 7 and 4, and then you might come out and say 7 and 4, visual alignment, wait for it to populate, and now you kind of get a true slicer. But if you can also, if there's a link, but there is not a link between 7 and 4, but if you click a link, like say, oh, 88 is between 7 and 4, interesting. Then you can go true slicer, and now you've got just a true slicer for that link, and you can constrain to the axis, which is our last key takeaway for today. What you see is what you get. True slicer is the most important, and that's a big differentiator between core, because to do slices is kind of tied to the model entitlement. In core, you had to be able to set a reference plane, set your slicer to your reference plane, then view your slice. Whereas in Register 360 Plus, it's just part of the software. So let me go back through and make sure I didn't miss anything I wanted to talk about. I think I got everything. Anybody got any questions? We can address those now.
We have had a number of questions come through,
don't doubt it.
Adam, so fantastic job. And kudos to Eric for keeping up with a lot of those. I'm going to start at the end here since Eric has been replying to all as he's been getting to them. We had a couple questions about the scanner. So you've been showing us scan data from the RTC 360. And we had a couple people who wondered if Register 360 Plus can be used with other laser scanners as well, the P series, other Leica scanners, possibly even other manufacturer scanners. Is that possible?
Yeah, absolutely. I'm going to stop sharing my screen for a second and Google real fast, because there's even some other brands that we import their raw data. Leica Register 360 data types import. And there's an actual, so supported file formats. You can bring in E57s. So even if we don't bring in a proprietary brand, you can export out of their software E57s, bring it in, bring that in Register 360 Plus. For the control files, text files, you can bring in individual photos, and you can actually even bring in videos and photo like wave files for geotags. But for scanner formats, you can bring in pretty much everything. Actually, you can even bring in C10 data. So everything Leica makes, you can import scanner wise. Looks like you can bring in Faro raw data, ZNF raw data, and other. If you can't do E57 with whatever scan data you have, we also do PTX, PTS, and TXT. So,
Sounds like it's a great all-purpose software for handling scan data then.
yeah, we tried to democratize, make it, accessible. So this, just if you don't have a Leica scanner, maybe you'd want to get one because our software is so good.
Of course. All right, fantastic. And then kind of a related question, I think, is there an option to set a non-Leica scan level?
I don't know about that. I know you can create UCS in a scan, but I don't think that applies as a control element. One thing you can do, and it's kind of a backdoor trick, is if you open a scan, you can create click 3 points, export, import those points as control. So you can manipulate those points, whatever you do, you need to level the scan, re-import them, register that one scan to those control points, and that would set it as level.
Okay, we had a couple of questions on this topic here, and that is, how did you unlock, or where did you unlock the tilt constraint?
Okay, I can show that real quick. So if you do not do the high tilt, I'm glad they brought that up because I meant to discuss that actually. So if you're going to put survey control, total station data on a site, and you're going to do 5 or 6 targets, I don't do high tilt accuracy at all because the software does a really good job of clicking the scans together 3D, and then you take that entire 3D bundle and you put it on your control. So you don't need that high tilt accuracy at all if you have survey control. If you don't, you might want to use it on like every 5th or 10th scan like we discussed earlier. But so here's 3 that I had. The first 3 I did with the level. It adds about 15-20 seconds to the scan. So that's another reason you probably don't want to use it if you're going to bring in survey control. But it's this option right here. So if I apply level condition, I'm going to say it takes the raw data, what it said was level. And for these, it did a great job. They are level. It doesn't even change the statistic at all. But if I want to remove level, having 1 on is the same as having them all off because they're all adjusting to 1 as far as your numbers and statistics go until you try to apply it to control. You don't want, like I would probably want this one leveled, this one leveled, this one leveled, this one leveled if I didn't have control. That way I got a good distribution. But if I just want to turn them all off because I'm going to put survey control on it, you just do it like that. Right click, remove level condition, and then that little level bubble gets a no through it on that icon.
All right, cool. Could you go over the meaning of the strength number again? Apparently that has been a little confusing for some users.
Yeah, I think honestly, maybe strength isn't the right number. It should be spatial. I don't know. Maybe it's probably the best number, best indicator. But so if you click this link, it has, see your strength kind of goes up and down between. So if you look at this one, if you pause, it says strength in the X is 66 and the Y it's 93 and Z is 100. So Y is probably this direction, and it's because I have a UCS. It looks a little different. And what it's saying is there's walls on this side, so we know that this link is pretty strong this direction. It's not going to move because you see we've got the overlap here. And it's saying for the ground, the Z is almost always close to 100 because you always have ground points. Sometimes you have ground and ceiling points. So Z is always going to be your strongest component. And then X, it's saying is weak because there wasn't much points oriented normal to this direction, up and down this corridor. That's really what strength means. And out here, like these are pretty low. it doesn't mean that they're bad or wrong. It just means that if there's an issue, then maybe they have some weakness to accept adjustment this direction, or because there's not a ton of data. So if you pause, it's Z is still 100%, but Y is down to 16%, and X itself is only 23, and that's because if you open this alignment between the two, like it looks like there's a wall here, but a lot of it's glass. So the blue, it only overlaps here. I can bring this strength probably way up if I just play games with the data and get rid of the area of low lateral overlap. And I say this is playing games with the data. Does not improve anything. It just makes the numbers look a little better. Strength went down. So, and that's because there's even less data in XY. That's what it is. So strength isn't an indicator of overlap. It's an indicator of how much data is there for it to work with on the different planes, the different spatial planes. And again, if you're indoors and there's a perfectly level floor, that's going to matter a little bit more. But if you're outdoors and your ground surface undulates, but it's still pretty smooth, you're going to get the right answer spatially because it's got a lot of irregularity to help lock. Now, smooth asphalt is a different animal than grass. So, grass is these numbers, you're going to get the right answer, but it's going to start floating up to hundreds or 200s between scans, not thousands. So.
All right, we are just over the top of the hour here. We're going to take a few more questions. I want to be respectful of everyone's time. Questions still are coming in fast and furious. I just want to let those of you on the line know that please do continue to add your questions. And if we need to end and there are questions that have not been answered, we will make sure to have someone from our reality capture team reach out to you and answer those questions for you. I want to go back, Adam, to the idea of tilt on the scanner, just because someone wanted to clarify that the tilt on the scanner should only be checked every so often. This person currently has it activated on every scan, and it sounds like that might not be a best practice.
It depends on the results you're getting with it. If you have it checked on every scan and you're getting really, like, the environment allows for it. So if it's flat floors, stable base, just keep in mind that it's susceptible to electromagnetic interference. I've been on sites before where, excuse me, I was next to this big AC belt-driven motor, and it's putting off this really nasty electromagnetic, had to been, because the second I set my scanner next to it, it said viz error. And the viz itself is based on the IMU. So when it started getting that electrical static across the chipset, it was like, I think I'm moving, but the cameras say I'm not moving, so that's a viz error. And it's also going to put an error on the tilt. So it's a tool to use, but I don't think I'd use it on every single, because if you have two scans 10 feet apart or 20 feet apart, it's not going to get the best 3D fit along that Z axis. So if you do high tilt on scan 1, don't do it on scans 2 through 9, then do it on 10. You're basically going to get, it's not going to be any less accurate, because at 17 seconds, your error is going to be, they're going to be skewed. They're never, maybe once in a million, you're going to get the errors exact same tilt. So you get all those scans. But even at that, it's going to be under 17 seconds. So really all you're doing is wasting that spin time if you do it every setup. I would do it every 10. Yeah, that's just personally what I would do, the results I've seen with it.
Okay, fantastic. Eric, I'm going to ask you to weigh in here real quick, just because we do have a number of questions that have come in. I want to make sure that we spend the last couple of minutes here addressing the ones that will be most useful to those who are still on the line with us. I appreciate all of you who have stayed on. We can stay on a little bit longer if that would be helpful to you. Eric, are there any questions that you would like to have Adam address?
Sorry, I'm trying to keep up. They just keep coming. There was one that asked, let's see, it said, what, I've got to scroll back up. They were asking about how to keep steam out of the scan.
Scan when there's no steam. That's the only option. I've ran into that before.
Or removing steam.
Here's a good one.
Yeah,
I don't think I don't think anybody has any software routine that deletes Steam, and it's because it's just dense enough that you get returns off of it, and it's something I've looked at before, and it's.
Yeah, there's so many questions here. I've just been trying to go through them one by one. I haven't even seen the bottom half here.
Yep, I'm going to ask this one. Are you creating the links one by one using visual alignment, or do you run find suggested links? And is there a way to run suggested links on the entire project? And if so, would you recommend it?
No, visual links, find suggested links is very handy, but I think it's got a visual element to it where if you zoom in, it's going to find links just in the area you're looking at. And if you zoom all the way out where you can see the whole project, it'll find them across the whole project, but less. So, and the reason for that is the original Register core, if you just would right click and select all of your scanned worlds and say auto add cloud constraints, it would try to do if say you had 100 scans, it would do 1 to 2 through 100, 2 to 3 through 100, 3 to 4 through 100, and it would just go through that exhaustively. And it didn't even have any spatial knowledge of if scan 1 is in a room and scan 100 was in a room in the top right and there's 0 overlap. It didn't care. It would try to look and say, well, okay, there's no overlap. Then we go on. Register 360 Plus has some. The thumbnails of each scan has some spatial awareness where the algorithm says, I know there's no overlap, so I'm never going to suggest that link. So I don't know if that helps, but it's a pretty nice intelligent feature, because if you right click, I do go around and say right click, add suggested, but I usually only do that. So I don't create them manually. I create them on the iPad. Well, I guess create them manually on the iPad, but then with best practices, good scan spacing, it's always basically 100% automatic. And it's really interesting because if you push it out to 25 on some site, if you bring that just back to 20, the extra 10 scans you might do will save maybe an hour in Register 360 Plus, because they just come in finished. And then you can just go through right click, add suggested, add suggested, add suggested, and you're finished. So I hope that answers the question.
Okay, excellent. Well, thank you, Adam. We are, I think, at this point, we are going to go ahead and end this session. Again, I know that there are some questions that we did not get a chance to address, but we will make sure that we have our experts reach out to those of you who did have questions to make sure that those questions do get answered. Thank you so much for joining us for this last reality capture education session of 2023. We do appreciate all your questions and comments, and especially your suggestions for topics that we cover in the future. And just because of the tremendous demand and participation that we've had, we do intend to continue this series into 2024. So please do watch your email inbox, check pure-surveying.com for those upcoming sessions. I believe our next session for this series is scheduled for February, so watch for that date. As always, links to additional resources and the recording of today's webinar will be coming to you in a follow-up email. Yes. I'm sorry, I thought you had a question. As you exit the webinar, please do fill out the survey that should pop up on your screen. We appreciate your time and hope that you found this webinar to be a valuable experience. Thank you so much.